what we should have learned through the investigation yesterday is transformations of trig functions, and this is a lot of lessons actually, but we condense it down into one because you've done it before, number one, and number two, we can really combine all of these into one lesson because they're all just different transformations of functions that we've spent time on earlier this year, plus what you did in pre-calc with trig functions as well. So this is a pretty quick review. Remember what the sine function and cosine function look like. Some basic characteristics we should always know is the minimum and maximum of sine and cosine are both 1 and -1. The period of both sine and cosine is 2 pi, meaning it takes 2 pi for it to repeat. Okay, so from maximum to maximum or principal axis to principal axis, it takes 2 pi to repeat. The amplitude, okay, so the amplitude is 1, meaning it goes 1 unit above and 1 unit below the principal axis. The period is 2 pi, so it repeats every 360 degrees, or 2 pi. So the period is 2 pi. It's doesn't have any phase shift unless it's not starting at 0, 0 for sine, or in this case 0, 1 for cosine. And then it also has a principal axis of y equals 0, okay? Because the middle line of the function, what passes through the middle of the function, is y equals 0 for both those functions. Now, tangent is a little bit different. It has an amplitude, which is really, it has amplitude, but you don't really notice it just in the basic function itself. All the amplitude change does is make it increase faster. So what you would see is you would see something like this, where it's increasing even faster than what it is in the basic function. So it does have amplitude. You don't notice it as much. So we still have to identify the amplitude. And typically the amplitude is 1. It still does have a period, except its period is only pi. It repeats every pi. So every time there's an asymptote, so every 1 pi there is an asymptote. So that's how often it repeats. And it does have a principal axis, which again typically runs down the middle of the function, splits the function into 2 equal parts, and it is again y equals 0. Now, it can be shifted up and down, but its principal axis runs through the middle of the function. So, a few things you should have learned yesterday, but before we get to that, is there's 2 forms of the trig function. There is one where b is outside, is actually outside the set of parentheses, so it's the sine of b times x minus c plus d. Or sometimes you'll see it with the b value distributed inside the parentheses. Typically what we want is we want to have it in factored, or where the b value is factored out of the parentheses, or if there is no parentheses, it's just the b value. If there's no phase shift, which we'll talk about in a second, phase shift represented by c. When you have that b value out, the b value is actually what affects the period. A is the amplitude, c is phase shift, and d is vertical shift, vertical translation. And that's a summary here. A is the amplitude, and it's always absolute value of A. We don't worry about whether it's negative or not negative, just simply reflects it to the other side. Period. The period is always equal to, 2 pi divided by b for sine and cosine. Okay, period is 2 pi divided by b, or pi divided by b. That's what is the period. Horizontal shift, meaning the phase shift, is what c represents, and the vertical shift moves it up and down. Something that's not really listed here that you get a common question to all the time is minimum and maximum. To find the minimum and the maximum, you simply take the d, the vertical shift, plus or minus the amplitude to get your minimum and maximum. If you go d plus the amplitude, that gives you your maximum. D minus the amplitude gives you your minimum. So you can easily find maximum and minimum from that information as well. Vertical shift is also representative of the principal axis. Y equals some value. Y equals d is the principal axis. So that's another thing you can add. And here's an overall general summary of what you see. So the principal axis is indicated here, y equals d, and then A affects the amplitude, B affects the period. It is not the length of the period. It only affects the period. And that's what you have to be very clear on. Okay? The period of a function is 2 pi divided by b. That's what the period is. So period equals 2 pi divided by b for sine and cosine. And period is equal to pi divided by b for tangent. And you got to be very specific with that, because that's one of the most common mistakes I see is students will write down b for the period. Well, it's not the period. It affects the period, but it is not the period. C affects it left-right transformation. Typically it's in radians, but it can be in degrees. If it just gives you a value, assume it is in radians unless it has the little circle indicating degrees. Assume it's in radians. And vertical translation is just the movement up or down. So we have an example, and if I give it to you in this general form, you might want to factor it so you can get it into factored form, especially that part. And here we're dealing with cosine. It has an amplitude of 3. Okay, so we can write down the amplitude of 3. What's its period? How often does it repeat? Well, 2 pi divided by b is 2 pi divided by 2, in this case, pi. So this function repeats every pi. Phase shift, that means it's shifted to the right. The phase shift is right 2 pi. So I have to start this out, right 2 pi. And the principal axis is at -5. Y equals -5. And all that's important to be able to actually graph them. So we're going to take a second here and we're going to graph this. And I'm going to start with this being -5, -10, 0. Okay, and let's do some phase shift here. We're going to make each of these pi. So pi, 2 pi, 3 pi, -pi, -2 pi, -3 pi. I'm trying to get my scale even here. All right, so typically, now we're going to start with, and this is, I always do this, there's my principal axis. So this graph has to oscillate above and below that line 3 units. Cosine always starts at 1, but here it's going to be 1 times 3, which is 3, and then -5. So cosine is actually going to start at -2 here, which is right about there. Now that's where it will typically start. So I take the starting point, and now I have to do some shifting to this. I've already shifted it down 5 units. I've done the amplitude a little bit, but I also need to shift this 2 pi to the right. So I'm going to take that little red dot, and I'm going to move it over here 2 pi to the right. And it has to make a perfect full cycle in 1 pi. So it needs to go all the way down to its minimum of -8 and back to 2, -2, in 1 full cycle. So it's going to go down and back up in 1 full cycle. And that means this is going from -2 to -8. And that cycle is going to repeat. So I've shown 1 cycle of this function. It needs to go down to -8, back up to 2, down to -8, back up to 2, down to -8. Oh, I'm a little far down here, aren't I? If that's -10, -8 is about there. So that means it's going to be, actually it's going to be about there. That means it's going to be about there and about there. So above and below this line, so. Okay, so its function is going to look more like that. And depending on how far it asks you to extend it to, I would need to go down to -8, back to 2, down to -8, back to 2, depending on how far it asks you to make it repeat or what the range it wants us to go through. So here I'm going from -2 pi to +3 pi. Okay. And it's a sketch. We don't expect perfection, but we do ask that you sketch them approximately. So this is -8. All right? So using some of those things to determine a graph of a cosine, sine, or tangent function. Here we use cosine to do all the different shifts and amplitude changes to a function. Transformations of trig functions.